today in anatomical kinesiology 310. We are going to be talking about, we're going to expand our conversation on muscles. I'm still trying to figure out where the camera is. I want to look at the middle, but I think the little camera thing is over there, so I'm kind of like, Hey Fluffy, you want to go out? All right. This is what I would like for you guys to do today. I'm going to talk about muscles in terms of doing a job. Last lecture we talked about muscles in terms of doing a job. Why do we have skeletal muscles to work, to do things? Do things dealing with motion, joint motion. They're going to either cause motion, allow motion, prevent motion, cause motion, concentric, allow motion, eccentric. They can even slow down motion, but they influence motion. Today we're going to expand on that by discussing what do we call it when they're actually doing a job, okay? And that is what we call a muscle or a group of muscles being an agonist. Agonist means the muscle is doing a job above rest. Agonist means doing a job above rest. That's who you need. That's who you need to do a job. That's who you call above resting tone to do something. Agonist. So the opposite of a muscle or group of muscles doing a job above rest is antagonist. Who do I not need? Who do I not need to do that job? So I'm going to give you an example. Just today, we're going to use two well-known muscles. We're going to use the bicep and we're going to use the tricep for our lecture today to expand on who's working, who's not working, okay? Now, what does the bicep do? Some of you would automatically say, oh, the bicep, that's involved in flexion. Flexion is a motion. But right away, I'm going to be like, well, let's not just think of it in absolutes. Bicep flexion. What if you're working overhead? Let me get my little weight. Okay. What if you're working overhead and you know this exercise is working the tricep, right? Well, when I start here and I do this, I have flexion, but yet I'm working the tricep. So it's not necessarily just about muscles with motion. We do not associate muscles with motion. That's one of your commandments. In other words, we can't assume, we do not assume just because we see a certain motion that it has to be because of a certain muscle. And that's the same thing in terms of what does a muscle do? We can't say the bicep is always involved in elbow flexion, okay? Because sometimes, as we know, bicep flexion, that works, but when I lower it down, that same muscle, I feel it tightening above resting tone, but yet I observe extension. Bicep flexion, bicep extension. And what about isometric? Bicep flexion. Hey bicep, keep me here. I still feel that muscle above resting tone, right? But I don't see flexion. It's still working. It's doing a job above resting tone, working isometrically to prevent my arm from extending. So instead of saying bicep flexion, I want to explain to you why that gets people into trouble. We don't say bicep flexion, bicep flexion. What's the function of the bicep? Flexion. Because 2 out of 3 times in terms of dealing with potential types of motion, if I'm doing a repetition of curls, bicep is not just dealing with flexion, just like the elevator cable isn't dealing with always bringing you up. Sometimes it's preventing you from falling down, other times it's letting you go down while still pulling up. So the biceps function isn't necessarily flexion, the motion of flexion. The biceps function is pulling in the direction of flexion, even though sometimes we do not see it. I know that sounds nitpicky and semantical, but it is extremely important. The bicep pulls in the direction of flexion. Just like a Major League Baseball team tries to win every game, but do they win every game? Of course not. They win while trying to win. They lose while trying to win. And if they go 9 innings, I know we got overtime, but in a 9-inning game, they can tie while trying to win. So what was the constant there? Not the outcome. The outcome isn't the constant. You can't always flex. You have to extend. So the constant there isn't the motion itself. It's the pull in the direction of motion. That's what's constant about the bicep. The bicep, the way it crosses the elbow and the way it pulls, the direction of pull, muscles can only pull. It pulls in the direction of flexion, regardless of motion. Regardless of motion. So think about the tug of war concept from our last lecture, right? If you are pulling, let's say we have a tug of war set up and external force is going to be outside of you, this is you. And let's say you're pulling east. Just pretend you're set up where your force on the rope is east, the external force is west. You're pulling on that rope in a direction of east, regardless of the outcome. If the rope moves away from you, you're still pulling east. You're an east puller, even though the motion may be west. East puller. If you're pulling and there's no motion, you're still an east puller. And if there's motion in the direction of your pull, you're obviously still an east puller. So that's the key here, is that it's about the direction of pull. The function of all these muscles is about direction of pull, not motion that is happening. East puller, east puller, east puller, east puller. Bicep pulls in the direction of flexion. Whether you're causing flexion, east puller, flexion puller, flexion puller, flexion puller, or in isometrics, flexion puller. It's pulling in the direction of flexion. Now, before I go any further, I have a homework assignment for you guys. In the comments, I want to see who's actually watching these things and who's just getting a notification and commenting that they watched it. So for today's lecture, if you're really watching, I want you to comment with the word done. D-O-N-E. Done. You understand? Comment with done in today's video lecture. Okay, now that that's done, let's go back to tricep, right? So bicep is in the front of the arm. And remember, the elbow is a uniaxial hinge. The only motion it has is flexion and extension. Bicep is in the front, pulls in the direction of flexion. Tricep is in the back. It's pulling right here. It pulls in the direction of extension. Bicep pulls in the direction of flexion. Tricep pulls in the direction of extension. If I had my elbow out on the table, tricep is going to be pulling this way. Bicep this way. Tricep, bicep, tricep, bicep. Let's talk about function of tricep. The function of tricep, what does it do, isn't just extension, because again, that would be vain to say that the tricep, who is trying to extend, pulls in the direction of extension of the elbow, but it doesn't necessarily always cause extension of the elbow. Does that make sense? So in other words, let's go back to our overhead exercise, okay? I know darn well that I'm working tricep the entire exercise, right? That's who's working above resting tone. But I also know in terms of motion, half of this exercise is flexion and the other half is extension. So I can't say tricep extension, because what happens half of the time when it's tricep flexion? Tricep is still working, but half of the time I observe extension. So the key thing there again is to not fall victim to just looking at muscles in motion, muscles in motion. In other words, tricep extension, if all you ever do is think, well, the tricep extends the elbow, you're going to be wrong. Two-thirds of the time, because what happens when the tricep is working and you don't have any motion? What you going to do? So how do we explain the function of the tricep? Not with a motion, it's with a direction of pull. The tricep is pulling in the direction of extension. And sometimes it does cause extension, concentric work. Sometimes it prevents flexion. Think of it. If I'm just holding it up here, it's doing a job, because if it didn't, my hands would fall down and gravity would cause flexion. It's preventing flexion, just like the elevator cable prevents you from falling down. Allowing flexion, causing extension, preventing flexion. So the key thing there is muscles are function in terms of what their function is. Their function is their direction of pull, not necessarily just a motion, it's direction of pull, okay? Who's working we call agonist. How do we figure out if a muscle is working? Clues. We need context clues. We need clues. We need to be detectives to figure out who I need to do this, to do a job. So let's look at clues in these two exercises. And again, we're going to use bicep, tricep, things people are familiar with, okay? How do I know? How do I definitively know that for this exercise I need bicep, and for this exercise I need tricep? Well, let's look at what changed. The weight didn't change. Still 10 pounds in this dumbbell. The direction of the straight line force didn't change. Planet Earth is still trying to pull this dumbbell down to the ground. So what did change? Well, here I know I'm using bicep. Here I know I'm using tricep. What changed is the motion that the external force, in this case this weight, is trying to do to my elbow. We're going to do a thought experiment. Easy peasy. What is this weight trying to do to my elbow? The weight is trying to extend me. Let's go back to our tug of war example and imagine that you can pull east or west depending on what you need. In other words, if the goal is to keep that flag in the middle and an external force all of a sudden is trying to pull you east, well, then you need to recruit muscles above resting tone west. Because if it's trying to pull you east and you use muscles that pull this way, it's going to sling that rope. If it's trying to pull you east and you don't recruit any muscles, it's going to move that rope. So if the point is to try to keep the rope from moving, keep it from moving, keep it in the same position, and I have an external force that's trying to move the rope east, I need to use muscles that pull west. And in the opposite end of the tricep, if I have an external force that's trying to move me west and I'm trying to keep it still, I need to recruit muscles that pull east. Notice this opposition, okay? Muscles move, or muscles work, muscles contract because they need to do a job. Preventing motion, causing motion, allowing or slowing down motion, okay? So the key thing to figure out who's working is to understand why they're working. Like if you were a detective and you have to understand why, the whys. I like to look at it as kinesiology Clue. Remember that game Clue? You got to figure out who did it. Professor Plum with the candlestick in the kitchen. So here we're figuring out, who do I need? Do I need bicep or tricep? Well, let's ask ourselves, why would I need bicep or tricep? In this case, the external force is trying to extend my elbow. If I actually recruited tricep, I would have weight plus muscle influencing extension. Weight and tricep. If I actually recruited tricep, my elbow would sling down faster than what gravity could offer. I'd probably hurt my elbow. It makes sense. I don't need tricep in this position. I need bicep. External force trying to extend me. I need bicep who pulls in the direction of flexion. So I'm going to recruit bicep here to do a job. What's its job? To prevent extension. In this case, to prevent my elbow from extending. If I go here, who do I need? I don't need bicep because weight is trying to flex me. If I recruited bicep, it would flex even faster than the weight. So in this example, I need tricep to do a job. I need tricep to do a job. So the key thing in that example is, how do we definitively know if a muscle is working? Because we need to figure out why the muscle needs to be working. And the way you figure out why a muscle or group of muscles, we're starting off with individual muscles in today's lecture, but we're going to expand that into groups. Because no skeletal muscle works by itself. It's not like the heart or the diaphragm. They all have help. We have to figure out why it's working. Okay? And the easiest way to figure out why a muscle needs to work is to ask this first question. What is the external force or forces trying to do to my joints? In other words, how is the environment trying to move me? In normal motion, human motion, 99.99% of the time, your motion is slow and controlled. That's in most exercises, activities of daily living. I said most, not all, but most. Now think about it. How often do you move faster than slow and controlled? So the point is that a majority of your motion, the group of muscles that you need are going to be pulling in the opposite direction as external forces are trying to move you, such as gravity. Okay? Gravity right now is trying to flex my neck, my cervical vertebra. Why? Because I have more stuff in the front of the teeter-totter than in the back of the teeter-totter. Gravity's trying to flex me. So if I want to prevent that motion while I'm looking at you guys, I don't need flexors. I don't need muscles that pull in the direction of flexion. If the teeter-totter wants to rotate in a direction of flexion, I need to pull with muscles that pull in the direction of extension. Your erector spinae muscles back there. Muscles that pull in the direction of extension are going to be my agonist, doing a job. And if I'm sitting upright, their job is to prevent me from flexing. And I see this in class sometimes when students are super tired and you see this, they're like, Gravity is trying to flex you, and you offset that by using muscles that pull in the direction of extension. Now, the key thing there in that example is that those muscles, these erector spinae muscles in the back, their function isn't extension. Sometimes, like if my head is down, their function can be motion in the direction of their pull, concentric, but not always. Majority of the time, these extensors, the muscles that pull in the direction of extension, are really working isometrically to prevent you from flexing. So that's their job. Their job is actually to produce no motion sometimes, a lot of times. Okay? So we have to ask ourselves, every exercise you do at home, again, don't go out in the gyms right now. Ask yourself, what motion is that machine trying to do to me? What motion is this dumbbell trying to do to me? What motion is this TheraBand trying to do to me? What motion is this weight trying to do to me? What motion is this bar trying to do to me? And when you can theoretically see what motions the weight is trying to do, like let's say I'm here, in the sagittal plane, the dumbbell is trying to extend my shoulder. It's trying to. Gravity is trying to extend me. And I could do a thought experiment. If I turned off all my muscles, the weight would extend my shoulder. So it makes sense. Who do I need to call above resting tone to do a job? My shoulder flexors. And those flexors can either cause flexion through concentric work, prevent extension through isometric work, or allow the extension through eccentric work. So notice, when the external force was trying to extend my shoulder, and I'm doing an exercise slow and controlled, in other words, I'm not going faster than what gravity can offer. We're going to get into those exceptions later. Notice, the agonistic muscles, the group who I need, stayed the same. The change in motion was not because of different muscles. The change in motion because of the change of contraction. That's the epicenter of today's lecture. Variations in motion in majority of your day-to-day activities is because of change of contraction type of the muscle. Let's look at our curl again, okay? External force is trying to extend me. I need to recruit flexor, such as the bicep, pulling in the direction of flexion. So I know, I can feel it, that I'm working bicep the entire exercise. I feel it. So if I'm working bicep the entire exercise, but yet I know that I am fluctuating between elbow flexion and elbow extension, how can I have something that's consistent, the same, yet something variable, different? What's the same? Bicep is working the whole time you're doing curls. That's true. What changes? The motion changes. The motion fluctuates between flexion and extension, flexion then extension, flexion then extension. So how can something that's constant, bicep, influence something that changes, changing motion? And the answer is contraction, different contractions. Concentric, shortening while trying to shorten. Eccentric, being lengthened. while trying to shorten. Same external force, same agonist, meaning that the entire time the external force is trying to extend me, I need to use a flexor, a muscle that pulls in the direction of flexion, such as the bicep. As long as the weight wants to extend me, I need to play tug of war with something that pulls in the opposite direction. East, west. Eccentric, concentric, eccentric, concentric. Bicep, 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 eccentric, concentric, eccentric, concentric, isometric. Same external force, same agonist. The variations in motion is going to be because of variations in work or variations in contraction. Same external force, same agonist. Variations in motion because of variations in work. Are there exceptions? Of course there is. They still follow the same rules of physics, but the exceptions are when you have to go faster than what gravity can offer. So in other words, imagine a carpenter needing to hammer in a nail. Well, in this case, gravity wants to extend your elbow. But if I play tug of war opposite of gravity, then I have to be moving slower than gravity. But you know, when you're hammering in a nail, you gotta go faster than gravity. So in these rare exceptions, you need the weight and muscles to be pulling in the same direction. That way you can go fast. So imagine the tug of war. Force wants to pull me east, my muscles pull east, you're gonna sling that rope across. So there are functional reasons why you have to go fast. Think about doing jumping jacks as fast as you can, sprinting as fast as you can. So there are gonna be rare exceptions where muscles and external forces, muscle forces internal, and gravity, weights, external are working in the same direction. But they're always gonna make you go faster than what the external force can offer by itself, okay? So, how do you determine if an agonist, whether it's a muscle or group of muscles, I'm gonna talk to you about group of muscles next, how do you determine if they are working? In a majority of cases, activities of daily living, exercises that involve slow and controlled motion, you know who's working because you can understand why they need to work. Ask yourself, this is the first step, guys. On this page, determining agonistic groups, it says step 1, analyze external forces. What motion, what joint motion is this external force or forces trying to cause? Now, I say forces. Now imagine doing a squat, right? Doing a squat, you're going down, coming up, going down, coming up. The external forces, in this case, you have planet Earth trying to pull you down, and you have the ground pushing you up. You know, you kind of have this squeeze effect going on. And if you think about it, if I relaxed all of my lower body joints, what would happen? My knees would flex. The external forces are trying to squish me in the fetal position. Think of it like that. Grounding gravity is trying to flex my hips and flex my knees, right? So if I'm doing a squat, going down, coming up, going down, coming up, and the external forces, in this case, grounding gravity, is trying to flex me, who do I need to call to play tug of war against them? If the external forces are trying to do this, I need to use muscles to influence all of my motion that pull in the opposite direction. So if the ground and the gravity, if ground and gravity is trying to flex my hips, who do I need to call to work against them? My hip extensors, such as your butt, your gluteus maximus, and your hamstrings. Who do I need in my knees? Well, if ground and gravity is trying to flex my knees, I need knee extensors. I need muscles that pull in the opposite direction of that. Who are my knee extensors? We need the quads. I need my quads. Now, you can't say the quads extend the knee. That's not fair. Because as I know, when I go down and come up, go down, come up, I'm working those same muscles the whole time. But yet, half of the time, I'm going to observe flexion, and the other half of the time, I'm going to observe extension. So the same muscles, the quads, the knee extensors, the muscles that pull in the direction of knee extension, half of the time, I'm going to see flexion, and the other half of the time, I'm going to see extension. So what gives? If those muscles are working the whole time, and that's consistent, the group of muscles that I need is extensive, the quads are working the whole time, but yet I see motion half of the time, what gives? How can something that's working the whole time produce different motions? Contraction type. Half of the time, those muscles are working concentrically, shortening while trying to shorten. So what are the quads trying to do? They are trying to extend your knee. So when you actually observe extension, when something's trying to extend you, doing what they are trying to do, shortening while trying to shorten, concentric work. And when you observe flexion, muscles that are pulling in the direction of extension, but yet they're allowing flexion, that's okay. Just like the elevator cable can allow you to go down while pulling up, that's okay, it's still doing a job. Eccentric work. So again, it follows this sentence. What's the external force trying to do while you're doing a squat? It's trying to flex your knees the whole time. Whether you're coming up or going down, it's trying to flex you. So if the external force is trying to flex your knees the entire time, I need the same group of muscles. I need the same muscles to do that job the whole time. My quads, my extensors. So the variations in the motion, going up, coming down, going up, coming down, isn't different muscles. It's the type of work those muscles do, contraction. So that's the key, is to understanding that in the majority of human movement, changes in motion isn't going to be different muscles. In the majority of your activities of daily living, the changes in motion that you see is going to be because of the change in the contraction that the muscles are doing. Variations in motion because of variations in work, variations in contraction type. All right? So I want to remind you, because I have a sneaky suspicion and proof that some people are not watching these videos. You got one job. I know this is crazy for everybody, but all you got to do is sit back, relax, watch the videos that I'm giving you credit for, but I need to make sure you're really watching them. It's my job as a teacher, right? I got to make sure that I'm teaching you something. So today you comment with the word done, D-O-N-E, done. That's your comment. That's how you confirm to me today on Monday, March 23rd. Done. Comment done. Y'all have a good day, guys.